Hello. So welcome, good afternoon. It's a common assumption that each microservice should have its own database, which makes a lot of sense for many reasons. You want to decouple all components in the stack, but it also comes with a lot of complexity. And the idea here is to explain what you can do with a database, especially with SQL database and distributed SQL database. For some microservices, maybe you can keep the same database and use some database feature to isolate and achieve your goals. So we have half an hour. I will go very fast because it's hard to talk about that without all details, but interrupt me if you have questions, do not hesitate. Basically, I will explain a bit what is the problem with databases and microservices, what can be good or bad having one database per microservice, and the opposite, what can be good or bad sharing a database between multiple microservices. I'm not saying all microservices, one database, but maybe a few ones. And then we will see the features that you have in relational databases, in SQL databases, in distributed SQL database that can help to do that. I'm developer advocate for Yugabyte. Yugabyte is a distributed SQL database. Basically, it's open source and Postgres compatible, so you can use it as Postgres, but it is distributed. Means that you can connect to any node, and the data is distributed, the processing is distributed. You can read and write on all nodes, and you will see that those features can help also. Let's start. Microservices and database are usually not very good friends. Let's explain why. In many places, the database is always the problem because the database has a state. When it started with monolithic applications, all components were tightly coupled, which is good to start, but after some point, the system grows, and then the productivity is difficult to follow the growth. This is where we come to domain-driven design, where we identify some smaller domains where we can work independently. The idea is that it is smaller for all the life cycle of the application when you design it, when you code it, and also when you operate it. So designing and operating smaller system. And then within those domains, you can have one or multiple microservices. The goal here is to have teams working autonomously on one of them. So it's always important to understand the goals, because we will see the features, and the features map to some goals. Basically, bounded context. The idea is that you have people talking the same business language, knowing the same business rules, and they can work together, collaborate together between domain experts and developers. So that's a good idea. Microservices go a bit further. Even within a bounded context, you may have multiple microservices. That depends on your organization. You do that because you may have different teams. You want different modules. You want it to be scalable, and the scalability requirements are different for the different microservices. For performance also, you want to control the resource allocation for each of them. And also for fault tolerance, the idea is that if you run multiple services and one is down, the others can continue. If you have a big monolith, something fails and everything fails. So that's the idea about bounded context and microservices. There is also the advantage that if you have multiple microservices, you can choose the technology, and we are talking about databases. You may want to use a different database for different services. But then, what about data that we will persist in the database? So if I take just an example from Martin Fowler's definition of bounded context, this is an example where you have two contexts, so very different business teams, but you can see that they share some data. That usually happens. There is some data that is specific to a context, but there is some data that is shared. And within each bounded context, you may have multiple microservices, because you don't want to do the same with online services, which have some requirements with data feeds, scheduler jobs, whatever. So technically, even within a context, you may have modules that you want to separate or do command query segregation. But they share some data, means that you have multiple microservices. But at some point, here you have an example where they share the customer base, they share the product base. And this is where you start to have a problem. And yeah, if you split to multiple databases, then you need to replicate data. If you keep one database, you have everything there, but not the decoupling that you wanted to do with the microservices. And the goals of microservices and databases are opposite. The goal of microservices, you want small components, loosely coupled. But for databases, the main goal when, especially relational databases, were built, the idea was consistency. Not having data in different places in the company, having a centralized repository, which is good to keep data consistent, but the opposite of microservices, because you have one central repository. Also, databases want to manage concurrency, sharing data between users. If you don't share data between users, you can use an embedded database, you can use file, you don't really need a database. And for performance also, databases try not to duplicate data. Because if you duplicate data, you have more work, you need more resources on the infrastructure. And for agility, SQL databases especially are built to allow adding new use case on the same database. You have a new use case, you think about a new service, but maybe in a SQL database, this is just a new view, an additional index on the existing data. They were built to do that, to have a big monolith for the database, basically. And going fast on that, those are some articles from the beginning of databases, and they all insisted about doing everything in the database. Even the code, even the report, that was really the feature. So the idea was really to have a monolith that stores your data and also all your services within one database. So completely the opposite of what we want to do today. But because this exists for a long time, a lot of features have been implemented within those databases to achieve some isolations. Because even if it was deployed as a monolith, the need to have different modules was already there, of course. And this is what we will see. So basically, you have two extremes. A monolithic database for all your services. Good to start. The first prototype is easy, the first release is easy, and then you will start to see some productivity that decreases, because if you have different teams, they need to synchronize because they have only one database. The other extreme is one database per microservice. This has a cost. This uses a lot of resources. You see that in the cloud provider bill, for example. You need also to think about consistency, because this data that is shared by multiple services, you need to think how to share it with keeping the decoupling, but keeping it consistent. So usually, the solution is in the middle between those two extremes. First, even with those monolithic databases, very often the OLTP and the analytics was separated in different databases. And You can also choose to have multiple databases per bounded context, but if you have multiple microservices in one bounded context, then you can keep the same database for that. So it's not do this or do that. It's more thinking about what you want to achieve that may depend on your application, on your services, and see how the database feature can help or if you need to separate them. So based on goals, you need this balance and think about why you need to split the database. I tend to start by thinking that if you don't need to split it, better to have one. But that's also from my background. I've been working a lot in operation as a DBA, and yeah, the more databases you have and the more problems you have. So do you want to split the database because you have multiple teams with different skill maybe and working on the different ones? Or is it for scalability and performance? So that's for operation. Do you do that because you have a service that may fail, but you don't want the other ones to fail? Or for performance, because you have a service where capacity planning is quite difficult to do, so you know you will have to scale this one, but without impacting the other. Fault isolation, fault tolerance. What is the reason for separating? Maybe you don't need all of them for a service, and maybe you don't have the same criteria from the business for them. And technology flexibility. Do you need a different database just because you are using documents, you are using time series, and you think that you cannot do everything in the same database? So that can be also a reason. It will also depend on the technologies you are using. So in the database, you have solutions, and we will see those solutions. But first, what happens if we decide to have one database for multiple microservices, one database, per microservice? So I'm going fast on that. You probably know the reasons, but the problem comes with shared data. Then you go to an event-driven architecture where you will send the changes from one database to the other. So you are decoupled because it is asynchronous, but then you have more problems to manage, like consistency. So that works, but that's not easy. You can work with multiple teams, but you will also need more people, probably. Consistency is quite important there if you have a service that updates the customer. Another one where the user will see the changes. Do you want to synchronize it? And then your decoupling is not so decoupled? Or do you accept that the data is seen later? So also, that can be a lot of data propagation between services. This has also a cost and risk of failures and all that. But first, when someone tells me, I want one database per service, I've heard that a lot, but what people call a database can be things very different. A database can be a schema within a database. So a logical namespace where you put your tables and indexes. And some developers will call that a database. It can be a database in the sense in Postgres, for example, where you have a database, multiple schemas. What is specific to one database is that there is a catalog of objects, and you cannot join tables between multiple databases. Keeping the example of Postgres, one Postgres instance can run multiple can access multiple databases. So one database, multiple database in it. If you are using Oracle, you have the pluggable databases, the container database. So that's another level. Here, you are still physically, with monolithic databases, you are still physically on one server, even if you have multiple databases. And that can be OK. And then, if you want more physical isolation, you want to start multiple instances on multiple servers. So a cluster of database If it is a monolithic database, the replicas are read-only. If it is a distributed SQL database, the replicas are all identical. Yeah, just to mention that for the youngest of you, if we represent databases like this, it's because they were stored on disk. So maybe a disk, hard disk is a database also. So what do we call a database? And also you have different kind of databases. If you want to decouple everything, having a database that it's not shared with anything else, you can have an embedded database like SQLite. It is a database, but it doesn't share the data between multiple instances of the application, multiple users. If you are using NoSQL, like MongoDB, DynamoDB, there you can call a database a simple table where it's a key value store, and that can be your database for your service. Probably your microservices do not need multiple DynamoDB tables. A database server with the read replicas, that can be a database, so you start to have multiple physical servers running it. And yeah, database cluster with many users. So what do we call a database? That's very different. And each level has some feature that helps to consolidate something, isolate some others. Then you need to think about what you want to isolate between your services and which feature you can use or not. And basically, when you go there, you have some that are loosely coupled, some that are highly coupled. And about the feature, what do you share when I'm saying that you share the database between multiple users? Is it only the structure? Is it the data? Is it the consistency, the ACID properties, where you have consistent view on the data? Many different cases, also many different level of coupling. So it's not like one database per service, very decoupled. Yeah, but if you need to share something, it is not. So basically, you have the choice, and you need to think about the goals. The risk I see if you decouple too much is that you have too many databases, and I mentioned that I've been working as a database administrator, and I've seen those companies with 4 people in operations and 10 different technologies to manage. And to manage means they need to know it, they need to patch it, they need to understand it, follow the versions, so a zoo of database. Because if you completely give the choice to use one database per service, and the team can choose the database they want, then globally in the company you will have many databases. You can also limit that. You can also say, okay, you have different databases, but please use the same, use Postgres, because it can work with your different services. Also, the complexity comes from the codes you have. If breaking into multiple databases breaks the consistency, if the database doesn't guarantee that when you update the customers, it is updated for all services, then you have to think about it. There is also a cost when you replicate data between services, and when you add a new service, maybe you need to replicate more. And there is also a cost when you test. If you have a microservice, you can test it, and that's very easy because you have your small service, but at some point, if they have to share data, you need also to test what happened, and that's more difficult. So you need to limit, understand what you need, and limit yourself to that. Also mentioning, just to warn you about too many databases, let's say you have 3 microservices, then one database per service, you have 3 databases. But in reality, maybe those microservices will be used by users in different regions, and for latency reasons, you will start a database in multiple regions, and you don't have 3 of them, you have 9 of them. And you want high availability. So each one will have a replica to fail over to it. And maybe you have some read use cases on them, and you want to read from a replica. So it's one database per service. Physically, to operate, maybe a lot more than that. If you put multiple services in one database, then you need to think about what you can isolate at which level. For example, in a table, you can isolate the rows from a security point of view. Guarantee, for example, if you have a service that must see only VIP customers, you can store that in a big customer table and ensure that this service can read only that with row-level security. That's one. The problem, if you put everything in a table, you share the same structure, and then if you need to update the structure, it will impact multiple services, so you probably don't want that. With schemas, you isolate, you have different structures, so that's good, but you still share a lot, like the catalog in the database. And if you have multiple databases, like in Postgres, multiple databases in one database instance, you isolate the queries, so that's quite good, but you still run on the same version, and when you have to upgrade Postgres, you will have to impact multiple services, which is what you don't really want. You can also achieve some physical isolation, even on monolithic databases that run on only one server. You can put your tables on or table partitions on different table spaces, which will go to different disks. But even if it goes to different disks, you still have one server, you share the memory, so you do not really decouple. Usually on monolithic databases, people start read replicas to physically have a memory disk on a different server, but you can only read from it, and the reads are stale because you update them asynchronously, because if you update them synchronously, you did not really decouple anything. And with those databases, you have still the problem that you have a single writer instance, and if it fails, then everything fails. I'm going fast on that. I just want to warn you about using read replicas for CQRS. So CQRS, you divide your services. Some are doing the writes and the consistent reads, and some other do not need consistent reads, and then can run elsewhere and maybe scale with read replicas. But if you think about it, you write to the primary database on a monolithic database. You write to a table. And for your read services, you probably create different indexes because it's a different access to the data that you need to optimize. And then you start a read replica that replicates everything, and this is where your read service will read from it. But you still have to create the index on the primary database. So you think you decoupled because you are reading on a different instance, but to be able to read on this different instance efficiently, you need to change the primary schema, and you need to replicate a lot of data. So it is good to separate and know which services do not need consistent reads and do not write, but that doesn't mean that you can run them on a read replica and it will be fully decoupled. And this is where I come to distributed SQL databases. So the idea is that instead of the traditional SQL databases that run on a single server, maybe you have read replicas, the idea is that all nodes are active with still maintaining all the SQL possibilities, ACID properties on it. And this solves some problems, not all problems, but some problems where you can maybe share more microservices on them. So you have the same SQL features, but because it is distributed, the application can connect to any node. All nodes are active. They see a single logical database with the SQL features to isolate logically, but they run on different nodes that can be even on different regions. And also, this is resilient because it distributes, but it also replicates. So you have solved your problem. You don't need multiple services, because if one is down, the others still run, because it will never be down. Even if there is network failure, even if there is a node down, everything continues. So if the reason for microservices is fault tolerance, here you have an infrastructure that is fault tolerant. So distributed SQL databases, this started with Google Spanner. There are a few others. Of course, I prefer Yugabyte, first because they pay my salary, but it's open source, it's Postgres compatible, that's very nice. And what can you do? What can you use in distributed SQL to isolate your workload? Table spaces. So in monolithic databases, table spaces will only isolate the disk. That's not sufficient. You can still have a query that will take all memory, all resources. Here, the table spaces are mapped to some nodes. It is distributed to multiple zones in the cloud, multiple regions, maybe multiple cloud providers, and you can map a table space to a specific region, for example. And then you can be sure that your service will run only on some nodes and dedicate them, which isolates for some failures, not all failures. I mentioned that with replication, many infrastructure failures, the database is still resilient, still runs. So that's just given. And for online maintenance, you still run on one version of the database, even if it is distributed. But because you do rolling upgrades, you do not stop the application when you upgrade. So you didn't decouple the version. If your application really needs different versions of the database, you cannot run that, but that's usually not the case. But at least you don't have to coordinate different teams when you want to upgrade the database or just patch the server or whatever. Operations can just do that, and the application just continues. So no need to split microservices for these reasons. Of course, there are other reasons to split. User errors. Some operations are run on a specific node. For example, if you terminate an instance, the distributed database will still continue because other nodes can take the reads and writes. But of course, if you just Terraform destroy the whole cluster, you will destroy everything. So for user errors, it really depends what you are doing. I think automation is much better than anything else to avoid that. And there is also something where it's quite difficult to isolate when you need to update the schema for a new release. In Postgres, for example, you can do DDL, so adding a column to a table, but this has an impact. So if you share the same table between multiple services, you don't want this impact on multiple services. There are some databases with online DDL where you do not block anything else. So maybe you can release a new application that needs a new column without impacting other services. I'm not saying it's magic and you can put all your application on the same schema, but you have more possibilities there because of those distributed databases. I'm going fast on that, just what I mentioned, that you can deploy on multiple regions. You can also control the data placement. If your reason for microservices is that you have a service that has data governance limitation, and you want it to run on specific regions, you can do that even if you share the database, just because you map that to the network topology. And just to mention something else, one other reason for multiple services was to choose different databases, document, time series, whatever. An example, in Yugabyte, there is Postgres compatibility, but there is also a Cassandra-like compatibility. So it's still possible to run with different APIs on the same database. That exists also in other databases. Oracle has a MongoDB-like API. You may need about that. Maybe you don't need a different database because you have a small time series somewhere. Maybe you can store that in a relational database. Today, relational database can store documents, can store a lot of different structures of data, can do text search and all that. Okay, I hope that was not too fast. In the slide, I just summarized that, but the most important is not the summary, is really thinking about the goals and what the database provides. And I'm not sure we have time for questions, but I'm there. And if you have any question about Yugabyte, about distributed SQL, or about SQL in general, do not hesitate. I'm also easy to find on LinkedIn or whatever. Thank you very much.